to spend time on that discussion. We've kicked off the live stream. I'd like to ask everyone to sign into the document. We'll post the link here for those that might not have it handy. While we're signing into the document, I'm gonna skip over new faces because I feel pretty confident that I know all of you. And we can move on to release planning and updates. Natalie, I think, give some updates on the life cycle.
Yeah, we're close to shipping 0.14. I think we're waiting for the specs to be released. That's should be soon, hopefully.
Awesome. And Javier, do you have any updates on platform?
I should have bailed before this question. Right now, the kind of top of mind, something I'm working on is a Windows related issue with samples. It might not actually require a new version to be released, but it might be too early to tell at this point in time. But if there is, there might be a new release for Pack as a patch.
Maybe a Pack patch that improves Windows support. All right, moving on to our main attraction for the day. Do you want to take it away, Natalie?
Let me go ahead and share my screen. No. Okay. You can see GitHub, right? Correct. Okay. So I made some updates to this RFC just before this meeting, just to make it a little bit more opinionated, kind of let people speak up if they don't like what I proposed instead of offering a bunch of options. So I'll just quickly go through it, and then I'll kind of linger on the areas that are kind of uncertain for me. So the idea is that platforms can provide SBOMs for run images. We are then going to put those SBOMs in a specific location in the final exported image. And there's a bunch of detail around how that would work in different cases and rebasing and that kind of thing. So as an example, when you run build, when you call the exporter, you can provide, the run image as an argument, and then here's a path or directory with the SBOM for the run image, and similarly for rebase. Then I propose that that SBOM be saved at this location in the final image. This directory is special because normally this is the ID for a build pack. So this would make base image a reserved build pack ID. And oh no, I didn't refresh since I updated. So let me go back. This is kind of approaching the place where I had questions. So kind of as originally proposed, we have a label containing the diff ID of the layer that has the run image SBOM. And it would be a separate layer from the one that has the build pack provided SBOM. This is to make rebasing more straightforward. I propose that we do some validation around the file types, like looking at the file extension, just saying, is this an accepted media type? And then this is new. I'm just bringing in stuff that existed in Anthony's pre-existing RFC that this one supersedes. Right now, build pack provided SBOMs are designated in the lifecycle metadata label. They have a special key there. But for parity with the base SBOM, we should duplicate this information in another label. I'm not sure how people feel about that. We were kind of iffy about it, back when it was originally proposed. But
And this is containing the layer diff ID
yes, yeah.
rather than having it in lifecycle metadata.
Yeah, I think it could be an additive. I have to, for the life cycle implementation side of things, it was very, very convenient to have it in here. But we can look.
Makes sense. I feel like either way we could make it consistent, right? Like, could we put, you could put them both in lifecycle metadata, or you could split them both out.
Yeah, it doesn't matter. It's kind of like, what do we like better?
Yeah, I was gonna say it doesn't sound like there's been a kind of defined convention on what goes inside of lifecycle metadata and what goes outside. Probably out of scope for this, but it may be nice to kind of create some sort of criteria so that this question doesn't always come up.
Agree.
So I'll just add that as a comment. I personally, I mean, I don't really care what the label is called, or whether it's in life cycle or not. But I will try to sort that part out. I updated this RFC since the last time we all looked at it to kind of explicitly spell out what happens when you rebase. Just that you replace the layer and you also update the label. I think this idea of like what happens when a platform provides a run image that already has the SBOM baked in. I kind of propose that we just take it, right? Like, just less work for us. The platform has already done it. This does still run the risk that the SBOM could be out of date, but if platforms want to avoid that, they can just never bake it into the run image, and then it's never an issue.
I know, Sam, you were the one who had some concerns around the run image SBOM falling out of date. How do you feel about this compromise? It sort of like has some of the same issues, but maybe you're walking into it more deliberately.
I mean, at the end of the day, I still don't get how a platform like Back would expose this. Like, what would be the idea if the run image already has this label and things set up? You don't have to provide. Like, I don't get the point of this if Back, for example, can already source, like, let's say we leave this part out of this RFC, and we make it Back specific that it sources SBOMs from like known formats, which is like cosine, like in-total attestations or cosine SBOM format or something else, or just scans it with SIFT on the go. Like, what benefit does having this in lifecycle offer that you can just solve it with Back there? Like, Back can just do this and then provide the file to the lifecycle using the flag.
I don't think that that's the concern, right? I think what we're saying is, what if the stack provider already has that information? Should we be removing it proactively? And I think the answer to that, I think hopefully we would all agree we should leave it alone.
Yeah, but we are introducing this convention for stack authors when there are already predefined conventions and tooling that they can use. In this case, we'll also have to provide tooling to create this label and inject the SBOM in the stack image.
Not necessarily, right? We could gear them towards, through conventions, to use the alternative methods, right? The ones, whatever we built into Pack, for instance.
Then I don't get the point of this.
It's just saying we're not going to remove it. right?
Head on for a second, and Forrest can correct me if I'm getting any of this wrong. But Keto Project's been really excited about providing like a full SBOM for everything for a long time, right? And I think there was some point where it seemed very likely that we're going to do this in the image layer. So there's basically already functionality that's like feature flagged off that could bake these things in. And it's not saying that, oh yeah, Paketo did this, so we should make it a top level feature. It's more like, what is going to be the convention and how long would it take to roll out and pack? So like, does not having this like make it, many months before we can provide a full SBOM versus if we had this, it's not a ton of work on the CNB side. And then
I think it's
people who wanted to provide it, it would work.
I think it's fairly trivial to just download the SBOM in cosine format and attach it. Like, I think if I remember correctly, Paketo had to do gymnastics with Crane to attach this after they'd created the stack. They would find it simpler to just use cosine attach SBOM to do it. And Sift, as of last month, just has a flag that says attach the SBOM as an attestation. So like, if you're talking purely in terms of ease and tooling, like you can do Sift, scan the image, like just run Sift on the image minus attestations, and you have it. I really
And I'm
don't see.
pretty convinced by that, but I think this is the argument. It's like, please, for the love of God, can we have a way to provide it? But
I would say that should be like, we should not invent our own standards if the industry is converging on one.
It's hard because we already did it in the app image, right? But I think,
I
just
think
because we're not ready to make that change yet doesn't mean we shouldn't do the right thing with the run image.
Yeah, I think also for the app image, the argument was that the lifecycle needed to maintain some state to restore response, that it needed to have control over. It's not the case with the run image. Like, the lifecycle or the build packs project doesn't create the run image. So I don't see a requirement for us to own how and where it gets stored and how we restore it.
Once upon a time, we did approve an RFC for create stack, but that needs some rethinking given all the other changes we've made to stacks.
I mean,
it never got implemented. Yeah, exactly.
So am I hearing correct? It seems like we're rethinking the whole idea of providing SBOM to the lifecycle and where they are stored on the lifecycle and the metadata attached to it at the label. Like, we're saying that whole idea shouldn't exist. Or are we just, if the stack provides it, we shouldn't accept it? I guess I'm not seeing why. Yeah, I don't know. Maybe I'll kind of leave it open for that answer.
I'm not saying we should change how lifecycle currently handles SBOMs. I'm just saying that if a stack author wants to attach an SBOM to the build image or the run image, they do so through tooling and conventions that are more popular than the one we're introducing.
But we're not introducing anything, right? It's basically saying like, hey, you could already have this information instead of the lifecycle attaching it.
No, but we are introducing this label. We are introducing the attachment format. Like, you can already attach the SBOM using the attestation format, and Pack could just download that and provide it to the lifecycle.
So what does the lifecycle do with it, right?
Just use it. Like, it's a directory of SBOMs.
Yeah, but so where should it go in the final image? I guess that's my question. Because that is us inventing our own standard, right? Like, that's us.
No, that part is completely fine, but this was more along the lines of what if this label is set on the run image, right? Not what if this is set on the output image. Yeah. Like the output image, I think like the the proposal that's there with the output format, location, and image, that's fine for now. We can change that in the future if need be, but like I'm just talking about the inputs.
No, I
Yeah.
guess what I'm getting at is, to me, it seems very flexible and robust if, as a stack developer, I could already provide the outcome that the lifecycle is going to produce. Right? Like that seems flexible to me. And
Or-
it sounds like what you're saying is like we shouldn't accept that.
But wait, why? So you're saying that the author would create this appropriate label, put the things in the RON image, and the lifecycle will then layer on the other things on top?
That's what I understood the RFC to be stating. Am I wrong in that?
Yeah, I think it's all it's saying is that this could be a decision that the stack author makes.
But
And the life cycle just take it, right? As opposed to, I don't know, like, you know, what would happen if the run image already has this label and we say, like, we just don't recognize that as an input, right? So it's either the case that the platform, they provide a run image, it already has the label, it already has the SBOM baked in. They don't actually provide a run image SBOM flag. You know, like then what do we do, right? Because like, do we say, oh, we're gonna strip that label off, we're gonna remove that layer, you know, or are we saying, oh, we're just gonna trust that whatever you provided, like you intended it for it to be there? Sorry, Javier, you have your hand raised.
Yeah, before I lose my thought, I think I found the counter argument for why we shouldn't try to have the stack authors provide that. And I think it's based on the idea of the platform API, right? At that point, the stack author would have to adhere to the platform API outcome, right? Because all of this is going to be defined on the platform API, if I'm not mistaken, right? And so let's say it's platform API 010, right? And then you end up with a lifecycle that now supports 011, and we happen to change where the labels are located, where the location of the SBOM, you know, ends up in. Then the stack author would have to, like, that just wouldn't work, right? Like the outcome of something that the platform expects would no longer be accurate to that aligns to the original input.
That's true, but it's true of all the requirements we make of stacks right now. It's like
That
it's
doesn't
all
mean
in
that
the
it's
platform
okay.
API, even though we expect them to be used in different platforms. Like I feel like that is a holistic problem that is not unique to this.
I
But it
mean,
would be a problem though, right? Like, I don't think we could ignore the fact that that would still be a problem. So adding more to the amount of things that could go wrong, I think is problematic.
I think one of the things that's interesting here is, have we thought in the rebase case sort of about what merging looks like, right? Because we said we were going to do that for certain SBOM formats like Cycle and DX, and sort of it doesn't exactly work, you know, with what we're talking about with the rebase. We're like, oh, I'll just take this layer, that layer. It's like, no, you need to actually do something with the data. But that got me thinking, and like, this is just, I'm not sure if I'm ready to stand behind this idea yet, just throwing it out here. But it's sort of like, I think the part that we really need to have exactly one way to do it with the SBOM stuff is for layer specific SBOMs. And it's because it's not just an output from the platform for users to consume. It's also like an input to a rebuild. We have to restore it to the layers. So it gets, you know, coupled into the build pack workflow. But I think the run image SBOM is not exactly like that. Like, so maybe it's worth opening up the question, like, the full result of everything for the app image. That's like the run image SBOM plus the other ones. Like, we need the layers in the image for the build pack generated stuff for rebuilds, but do we want to take all of that and then let the platform put that somewhere else, similar to what we were talking about on the run image, like in a cosine attestation, rather than putting it in the image? And then a rebase would just generate a new one of those. It wouldn't be like rebasing it somehow,
That's what my original plan was. Like, if you were not baking all of this into the image, the rebase case was trivial in some cases. Like, let's say we don't even talk about merging things. Let's say we just talk about like storing SBOM separately and have some other tool for merging and uploading it later on. Like, even then, if everything was just attached to the image rather than baked into it, like a rebase, just like all the information required to get the final SBOM from a tooling that understands it is already there when you do a rebase. So like these attachments can be found out from the digest of the base image, which is already stored in the lifecycle metadata.
I guess what I'm saying is, like, right now we have these workflows that work not against a registry, right? Which is why we've gotten into this layer business. But when it comes to regenerating the final product on a rebase, I don't think we actually need all of the previous product. Like, if we had the things that we already have in layers, like the build pack provided SBOM, and then we had the run image SBOM from wherever it is, you could create a new attestation without having to find the other one sort of as a platform, right? So we're not depending on, I'm trying to avoid is depending on having a real registry as an input to make an accurate build. Does that make sense?
We still need a place to find the SBOM for the run image, right?
Yeah, but if the platform can handle that, like give the SBOM, give the run image SBOM into the lifecycle, and then the lifecycle just gives it back to the platform. The platform can handle where it goes after that.
I mean, there's nothing stopping a platform from doing that right now. That was also the point of like the cosine RFC. It already proposes that the cosine binary or whatever we generate do that. So like the idea is, once the lifecycle is exported everything, we know where these SBOMs are kept, like by the lifecycle, and then it can just attach it in whatever format it needs. The lifecycle just stores it there for internal bookkeeping or whatever, and we don't really care.
I feel like the reason we need the lifecycle wants to have more guarantee that the layer SBOMs are actually the layer SBOMs.
Yeah,
is why we end up baking them in, because you could get really weird results from your build if you restore the wrong layer SBOMs with your layers, right? So I think that's why those particular ones need to be baked into the image the way we're doing now. But I don't think the same requirement holds for the run image SBOM.
Yeah, I mean, at the end, all of this is just so we have a way, like some tool exists to extract all the SBOMs and provide it to the user. Like we don't need to store it in some way. We don't need to handle it on our own. We just need some tool to piece all the metadata together and output whatever needs to be outputted, and do so in a convenient fashion that is well defined. Like I think that's the actual problem rather than trying to store the SBOM. The only argument for having the SBOM in the image is that I know tools like SIFT are going to support SBOM discovery within the image. So if it finds SBOM files in the image while it's scanning those images, it's going to augment its output with those files. That doesn't mean that will also not take into account like attachments or other things attached to the image, but like for things like the random tar walls that you've downloaded and you want to provide an SBOM for that, like that was the main reason behind providing such a functionality like discovery of SBOMs within the image. You could potentially use it to have SIFT automatically support build back SBOMs in the way they're currently stored, but yeah. It also would mean that like it would still download the entire image and scan through the whole file system rather than just downloading that specific layer. That's a different story. I mean, I agree that like with layers for bookkeeping, we needed to put it somewhere that we control. For the run image, we can just do whatever we want. If we still want it in the final app image for bookkeeping for whatever reason, we can put it in the app image. Otherwise, we can just leave it and provide tooling that can extract it and provide the final merged SBOM to the users. Like the end goal is not storing the SBOM within the image, right? The end goal is providing a complete view of the SBOM given a build backspace image.
Yeah, it's letting platforms give users an SBOM that is accurate. That's the goal.
Yeah.
I think maybe this gets into like a question that Stephen raised last week that might help us answer some of these questions. It's more like, do we want, is it important to let stack authors, do we want to encourage stack authors to be the ones that are doing the process of generating this? Or do we want to sort of like let platforms take the reins in scanning and generating? I think those result in kind of different trade-offs. And like maybe if you're the one who built the stack, you can know certain types of things about it more accurately, so you can make a more accurate SBOM. But I do worry that that is sort of like fighting the introduction of like the Dockerfile features and stuff like that, where it's like we're changing things on the fly. So we need to be able to dynamically generate the SBOM on the fly as well.
I mean, you can have the best of both, right? If the platform, whatever it's using to generate the SBOM, can just take into account, like the flow that I was imagining was something like this. You ask, Pack has a SBOM, like SBOM download command that merges and provides the complete SBOM to you. And the way that could work is if the run image you're using has a SBOM attached to it and one of the formats that Pack supports, Pack just uses that. If it doesn't, and you really want a complete SBOM, Pack can just run a SBOM generator on the run image and generate it for you. So even if you're on an older platform or build back API or whatever that doesn't support this thing, you still get your complete SBOM. Like even for past images that are running in production that have already been generated and you want an SBOM for them, you can do that. And then if you create a new stack with a run image that has an SBOM that you have provided and is more accurate back just sources from that instead of trying to generate its own. And at the end of the day, there's like really a handful of platforms. There's just like 3 platforms. I never get why we think that we should generalize this problem for like N platforms. There's just like 3 platforms, out of which Pack is the only one it's like going to handle things like this, like inspecting metadata or things like that. Like Tecton is not going to handle inspecting or downloading SBOMs for you. KPack has a CLI tool that, again, like it's not a platform. The CLI tool is not a platform, it's just a tool. KPack, again, is not going to handle all of this for you, like downloading, extracting SBOMs and stuff. It's like at the end of the day, it's just Pack.
There are other platforms, right? Like Waypoint and Google App Engine, but I think there are 2 prototypes of a platform. There's the like CLI imperative platform, and then there's the Kubernetes declarative platform. Like, you know, if the Spring Boot plugin is basically a re-implementation of Pack in Java, that's another platform, but it's Pack-like, right?
And like if we just provide a standalone tool that can generate SBOMs out of build Pack images, like anyone can use that. You can embed it in Pack. You can use it wherever. Like we have something like this, like a prototype tool that does this. It's trivial to create. Like even the merge, if you are not pedantic about like how you want to merge SBOMs, and you're fine with a flat list, and you're fine with trusting something like SIFT or whatever else to generate your base image SBOM, you get the full output SBOM right now. I think it's just a tooling problem from like fetching the SBOM and outputting it. But if we want deeper integrations, we can also do whatever we want to do. But like whatever information we want, we already have it.
I guess my question is for Natalie, is how useful is this discussion to taking the next step on this RFC, right?
I mean, on the one hand, I'm sort of hearing maybe we shouldn't do this at all, right? Or at least not in the life cycle, right? In which case, you know, we kind of have to start again, right? With I don't
think it's we shouldn't do it all. It's more like we shouldn't do this layer input, right?
Yeah.
And then we could talk about layer output as well, but
I guess maybe that's the first question to answer. Do we want the run image SBOM to be baked into the image, or do we want to let platforms decide where it should go?
I'm of 2 minds about that one. I think the lowest friction option would be bake it in for now, because that fits with what we're doing with other things. But I could see that in the long run, we might want. I guess if we bake it in, there's no harm, because platforms can also just put it somewhere else, right? It just might not be the default way I would think about it as an output in platforms, if that makes sense.
But if you're putting it somewhere else, if you allow platforms to put it somewhere else, what's the spec here? You know, what will be the specification? What are you trying to achieve at the end? Because, yeah, I mean, I look after a Java implementation that's sort of parallel to the Spring Boot one as well. So as a platform, I try to implement a spec to know what I'm trying to create, what I'm trying to output. and either I'm going to meet that or I'm going to not meet that. And if there's something there that says that there's flexibility in where something goes, then I question how anything downstream is able to consume it, because you know what I mean, it's confusing to me there as to what we're trying to achieve with it. It's either got to be in a place and everybody has to put it in a place, or it's documented how to get there. Am I making sense?
Yeah. So that's what I was saying. Like we can provide some tool that extracts the appropriate SBOM and everything for you. Just doesn't have to be part of the spec. Like, or everything that a tool needs to extract the SBOM is already there.
I don't get that. If you're going to provide a tool, immediately I've got alarm bells going off as to what platforms, what processor environments, and such is that tool going to run on. I mean, I'm running, as I say, a platform that's written entirely in Java. I can't really go exec something out because I don't know what system I'm running on at that point. So, and I don't really want to spin a container to do that because if I'm doing that, essentially I'm calling a lifecycle binary, right? So then are you saying that the tool that you're going to provide would be akin to a lifecycle binary, i.e. it's another phase that I would run that would do SBOM generation?
Not SBOM generation, but just fetching. So like, I think we are well beyond the scope of a buildpacks platform in terms of fetching in SBOM. The platform, a buildpacks platform is responsible for providing the environment and orchestrating the build process, not fetching things, not creating things. That's like something that Pack does, but Pack is also more than a platform. It's just a CLI of useful utilities repackaged together. Like, why would the Spring Boot plugin need to fetch SBOMs, for example? Wouldn't it just
I'll give you the Spring Boot. The Spring Boot plugin has to meet the specification of what a build pack platform is. It has to meet that specification. So if that specification contains stuff saying that gen packages needs to be run in order to generate SBOMs and stuff like that, then it has to invoke that. And therefore it's going to be playing in that field.
This is not gen packages though. Like
no.
That's for dynamic run image stuff. This is like a static base image. And as an end user, you want the full SBOM from your output image. Like, this has got nothing to do with how you're generating SBOMs or whatever. Like, at least this specific RFC has got nothing to do with that. It doesn't at all say anything about gen packages.
I mean, that's just as an example, because it's playing. We've got that's an example of stuff that is in the platform spec at the moment, so it has to be met. So I just get twitchy when you start saying about things that it doesn't have to be run, or this isn't part of this, or we can let it be baked in, or we could make it something for the platform to decide. I don't like that last phrase. The last phrase, making it something for a platform to decide, is basically saying that the platform spec has leeway about what it's going to do, which means that at the end of the day, the output image could vary depending on which platform it was built with.
That's already the case.
Why?
Because there are so many things a platform can pre-process or provide as inputs to the lifecycle. Those inputs are not reproducible across platforms. You won't have the final image that's reproducible.
But that's where I struggle, because that should be the case. Because if you've got a project directory that contains the same input and you're running it with the same build packs, it shouldn't matter which platform you ran it against. You should get an equivalent output image. There's been a lot of effort into trying to make that happen, right? That's why all the dates inside the image are set to 40 years in the past.
I think we're confusing two things. The whole reason the platform spec exists is to allow vendors to have their own vendor-specific logic in the platform that affects things. There's nothing that says the platform, like different platforms have to generate the same output image from the same set of build packs.
Okay, then I think you've got a very different concept of what the platform specification is for than I have as somebody who has had to implement a platform using the platform spec. Because the platform spec spells out must not, should not, using the RFC terminology. That's defining how to implement a platform. If you're doing things beyond that, on top of it, then I could see, if you're sort of extending, that's one. But if you're creating a different output image, then arguably you haven't met the platform at that point.
As long as I'm following all the must and must nots, I can do whatever I want beyond that as a platform. There's nothing that says I must not do anything outside of the spec.
I feel like I think there's room for some decisions for platforms around the edges for some of this core stuff. It's, like which major version of SIFT JSON do I want my SBOM to be in, something like that. It's the kind of thing where you can imagine platforms wanting to make different choices about some of this stuff. But I do agree mostly with Ozzy here, and that the idea is that, platforms can provide end users with different user experiences, and maybe with different additional features, or that different ones fit better into different workflows. But the idea of sort of having the core spec in the center of it is that, if you're running the same app, same build packs, same stack, you should basically get the same thing at the other side, similar to, any tool that's building your app from a Docker file should be producing. I mean, it's not, Docker files aren't nearly as reproducible, but you know what I mean? It's sort of like this core idea that you're like, I can take this operation and drop it into a variety of contexts.
So I think the question in my mind is very similar to Project Descriptor, though, right? It's whether or not we want to make that decision to be inside of the platform spec or outside, as an optional platform, sort of just additional tooling.
I mean, we already make this assumption in a bunch of places. I don't know of a single platform that can reproduce the other platform's output exactly. And it's like not even minor changes. I see some major changes between two. Like, for example, Kpack puts the input git commit SHA and the project source information in the output image, whereas Pack doesn't do that, which is a huge thing for me. Like, that's an important piece of metadata about the input that I'm not capturing in the output.
I think the spec allows any platform to do that. And this is where you get into the edges, like which features are a platform using. I don't think you can tell a platform exactly what to do, but you can say, if you're doing something you call X, here's the shape of what it should look like.
So isn't that what Natalie's RFC is? If you want to provide an SBOM, here's how you do it.
Yeah. I feel like I've sort of lost the thread of what it is we're arguing about exactly.
Yeah,
I'm going to be honest.
My only, I think the only sticking point was baking the SBOM in the run image in that specific format. I'm fine with defining a way for the platform to say, here's the SBOM included in the output. But I'm not so sure about just sticking it in the base image.
So there's nothing preventing us, we can't prevent staff authors from doing that, right? Someone could think I'm being very efficient here and I'm just, doing some work for you. And so that paragraph isn't to say that we should even we should advocate, we should recommend it, we should advertise that this is a way of giving the input. It's just saying, what do we do in this edge case, right?
Like the app image is an extension of the run image. Are we going to remove something from the run image? We've never done that before, I mean,
if someone sets the IO build packs lifecycle metadata in their run image right now, we will do that.
I think removing a label.
I mean, we'll just override it, right? But
yeah, we'd overwrite the label. This would be also a layer. Would you be taking the layer out? Would we then overwrite the layer? Would we white it out? Would we only do that if we had a new thing to overwrite it with? That's the question.
If the run image right now has a /workspace directory or a /layers directory, what would happen? Because this is gonna put things under /layers /something. So you're saying that.
I feel like that actually is one of the slightly weird parts of this, in that if we're doing something on the run image, we would normally we wouldn't put it in layers. The layers is sort of the workspace for the build, right? We'd move it somewhere else.
Yep.
I feel like that was sort of a different discussion though. I feel like if we're baking something into the run image, it lives elsewhere. If we're baking something into the app image, it lives in layers. But I don't think we actually do things to guard against things in layers in workspace. We just sort of tell people not to, you know.
I mean, it just feels weird to me that we're, like, as an optimization, exposing lifecycle internals to a stack auth. Like, if we have to change the layers directory, for example, let's say the layers directory is something else that was provided by the platform during runtime, and the stack author hard coded it to /layers/whatever. Now what do? Like, there are so many edge cases you'll run into with that.
So should we just say like a run image with an SBOM baked in is unspecified behavior, right? Like just like everything else that we just mentioned, you know.
Why would you even bake that in? It's like trying to guard the spec against a run image with /layers directory is unspecified behavior. We don't do that right now. Or we don't say a run image with IO build packs lifecycle metadata is unspecified behavior. We don't put that anywhere in the spec. Why make a special case for this?
So you're just suggesting we take this part out.
Yeah.
Just say nothing about it.
I mean, that's what we do for everything else right now. Like, there's so many things that, like, we tell what happens if the run image includes a /workspace directory, for example. We don't say anything about that. We don't say anything about /layers. We don't say anything about /CNB lifecycle. Like, a run image can have that.
Off question though, should we be saying something about that?
I mean, potentially we can include a list of protected directories that the stack image.
It's possible because they're all configurable though.
Yeah, you know? Exactly.
Like maybe we've made more things configurable than we should, but there are situations where people end up wanting to configure them for specific reasons. So it's hard to try to lock some of that stuff down. So
basically you're saying that there's ways this stuff can go wrong that they can't know it's going to go wrong until it goes wrong.
We can warn against it in our lifecycle implementation. We can, but then that means the lifecycle has to inspect the run image, which it doesn't do right now. Like, it just assumes the run image is on the registry. In this case, it will have to pull it down, extract it, check it.
We could output.
You raise a good point that you're not checking it at the moment and you don't warn about it for other things. Therefore, why should this be the first point that we care about it? I'd argue in response that if this is the first point where we're now becoming aware of just how many places that kind of problem exists, that fair enough, let's not deal with it in this case, but we should raise an issue to visit this again across all of the different places where it is, because it's like this one doesn't, it's not right that this one gets a free pass because everything else got a free pass once you know it's wrong, right? You got to go back and fix the wrongness. How that gets fixed isn't something that, you're right, how that gets fixed isn't something that should be part of this item. That part I will concede. You know, it's, you don't want to try and fix the world just because you're trying to introduce something, but you do have to acknowledge that it's broken, and you do have to go back and figure out how do you want to address that particular issue in the future for all the places it applies to.
The thing that's theoretically broken here, though, I think you're right, we could put in stronger guards to protect for some of this behavior, but it is very much an edge case. Like in our years of existence, I've never seen it happen, you know.
Yeah, I came slightly unstuck when I wrote my platform that I didn't use the same names that everything else expected, and some stuff did fall apart until I realized what was going on. But yeah, so it does, the problem does exist out there, but you're right, because it's configurable, it's so much harder to figure out. You can't just release a list of directories people should avoid, because that list would be different per platform, which would be, and maybe even per arguments passed to a given platform as well, which
if we were going to start cleaning stuff up, I feel like the first place we'd start is right now, like we say certain things are configurable, but you can't configure them differently on a rebuild and get the same result.
Mhm.
So
Yeah, kind of
versus,
model.
yeah, we could
Yeah.
guard against a lot of stuff like that in the future.
But like exactly things that you talked about, like the location of the app directory or the layers directory, that's different across platforms too. So your output image is again different across platforms.
Yeah. Yeah.
Oh, this was fun.
Yeah.
I
Yeah.
think, like, at least for this RFC, like, I would be happy if we can just expose that flag for the platforms to provide an SBOM. We can store it in the output image as we said we would, so that there's a consistent way to put things in the output and to download it. And then whoever wants to do things apart from that, like attaching it or like storing it in some other format, can do so via some other tool.
I do think we should talk about what Pack is going to do. I feel like
Yeah.
if we, like, this all feels good to me for the life cycle, but if we came out of this and then like I as a stack author do not know how to provide my SBOM still, then I
Yeah.
feel like that's a failure, you know.
We're over time, and the other meeting that Stephen's able to join is starting. I put the Zoom for that in the chat if anyone would like to join, didn't have the information already.
Should we continue it here, given that this is recorded and people lose context?
What a good idea.
That
Oh.
makes so much sense.
Yeah. Well, I guess let's just message Stephen and let him know. I think he's the only one.
I can only make the first half of this, I'm sorry.
Same.
Can we formally take like a 5-minute break? Let's come back.
Morning.
Hey, everybody's just taking a break between the two meetings.
Got it.
That was less than 5 minutes, but I see that everyone present who had their videos turned on before. So I do wonder, as sort of a selfish request, we just spent the last hour talking about the run image SBOM RFC, and I think to my ear, the consensus was we like having the run image SBOM in the app image. We want to give flexibility for platforms to supply the SBOM at build time by providing like a path as an argument to the exporter. But we don't like this sort of like edge case that was called out in the RFC, which is what happens if the run image has the SBOM already baked in at the expected location with a label identifying its location. So basically, what happens if the staff author did the life cycles work for it, right? That kind of creates a very strong coupling between the stack and the platform API, which exists today, but is a source of concern. Did I get that correct? Nobody said anything.
I think so, yeah.
Yeah. Yeah. Like, in other words, like we could have actively discouraged, right? As an input, putting the SBOM in the run image. Right? I think I'm.
And then we would elaborate.
Sorry, go ahead.
And then we could elaborate on ways it could be provided as an input to pack, right? Like either directly or in a registry case using cosine attestation.
And that does make it so that, unlike with the earlier proposal, right? If you're in sort of a logicless platform like Tecton, you're kind of on your own, right?
I feel like something like the best case for something like Tecton would be like a step in the Tecton pipeline that like runs sift and just uses the output every time.
the RFC sort of calls out the possibility of the CNB project providing like a preparer, kind of like a preparer binary that, among other things, could locate the SBOM.
If we really want to bake in some spec, I would just prefer to use the cosine attestation one, given that's most popular right now. Like if you really want to bake something in. As opposed to creating a new way of baking something in. If we want lifecycle to be aware of something attached to the run image that contains the SBOM, I would just prefer using an existing standard.
So I think I'm missing context about like where this conversation is kind of starting from. Is this about the Dockerfile RFC, or is this just about the run image SBOM?
We've been mostly talking about the run image SBOM. I think it intersects with the Dockerfile RFC in that once you're generating Docker files on the fly, like the BYO SBOM is almost guaranteed to be out of date, right? So then it's like, how does run image SBOM choices intersect with the details of how we generate SBOMs after running Docker files?
So in the Dockerfile proposal, there's a binary that lives in the image, right? Is that still there? Did we change that, right? That always gets run after every Docker file that's responsible for regenerating the SBOM, right? And so that keeps it up to date. Is there a concern about that portion, or?
Yeah, maybe it would make sense to, I can share my screen because I called that out in the run image RFC. Let me see. What can you see? You see GitHub?
Yeah.
Okay. Yeah, so I think the idea, the gen packages binary, I think the latest in the Docker files is that it would be provided by the platform, not necessarily baked into the base image, but kind of same idea, right? The lifecycle will run it when it applies Docker files. I did have a question. So that's the first case, right? The run image is extended with Docker files, then we run gen packages, and we update the, well, so now now I have questions, right? Because sort of we just said the thing that we've been debating for the last hour is, if we specify the location of the SBOM in the exported image, it's possible that a run image could come with that SBOM baked in. And then what do? Do you fail? Do you ignore it? Do you override it? What? And I had sort of said that we should just take it unless the platform specifically overrode it with a flag. Then we'll update it as if we were rebasing it. But I think that this caused some concern because it's like us inventing our own standard for associating SBOMs to images, and that's confusing. But let's say we don't allow this, right? Let's say that we just tell, like, highly discourage, like no one would ever think of this, right? Maybe if I hadn't said anything, this would never come up, right? So if we kind of proceed to Docker files, right? After the run image is extended, you have a way of generating your own SBOM, which is up to date, right? And I guess in this scenario, we wouldn't update this label on the extended run image. We would just capture the output of gen packages in a file or directory and pass that to the exporter, right?
I want to like maybe back up a little bit to like the user experience that we want to see like in the long term, right? Right now we have an app image that has pieces of an SBOM inside of the app image, right? And we like, I think we kind of view the app image as something where we're generating this thing contractually. It's going to have some things that are specific to the project in it, like fragments of an SBOM distributed in different places, right? It's like it's definitely safe for us to call that app image artifact, you know, like a build pack generated, build pack managed app image, right? We are like, there's a private API and a public API, right? With the kinds of metadata we add and how we interact with it. In the past, we've said stacks are the same thing, right? We've said a stack image is also build pack managed artifact. You probably use a build pack tool to generate it. It has build pack specific metadata on it, right? Like it could also have, it would feel consistent with the API for it to have fragments of an SBOM inside of it, like maybe that cover the different layers if you ran the different Docker files against it, right? Like to be consistent with what we're doing in the app image, right? I could see an implementation. This is like Anthony's original, RFC for what a run image should look like. Is it has, an SBOM, maybe fragments of SBOM in it, right? That look similar to an app image. I think we're moving away from stack image being a build pack managed artifact is my instinct, right? Like I open the RFC that says we're getting rid of stacks. It's just going to be, we're going to call them base images. And they're just going to be, that format. And that makes, using that same build pack specific API for storing SBOM in a stack image seem like we're doing the wrong thing now, right? And I think it comes up in a few places, like, Sam, you keep pointing out, like, well, now you have to construct this thing image in a special way, and if you want to extend it with a Docker file before the build, it leads to all these, problems, right? And so I would say if we're really moving that direction of a stack image can be any base image, and we're going to start accepting Docker files, like you really don't have to do anything special, right? Or the only special things you have to do to that base image are following requirements that are, already existing requirements you'd have for a Docker file, like setting a user ID, right, to a non-root user. That's not it doesn't feel very build pack specific, right? Then I would say we shouldn't include the SBOM in the run image at all. But do we, in general, do we feel like that's a feasible end goal? Are we aligned that base images should not be kind of build pack specific? They should be whatever Docker base image you want to bring into your build with extra responsibilities that aren't build pack specific, but may be important for our API, like API compatibility and setting UID and group ID as numerically, potentially, right? Does that make sense? Do we feel like that's the direction we want to move?
I feel like our remove stacks RFC does not get us 100% of the way there, but the difference between some random image that we pick up off the street and an image that would work is small. So you can imagine smart platforms handling that, or eventually us making that something that could be handled dynamically on the fly, right?
And currently it doesn't, you don't have to do anything but metadata manipulation to make it compliant, right? You just have to edit the config blob. You don't have to add new layers. So
I think the requirement to like bring a binary called gen packages feels onerous. Like when we were talking about it coming on the base image, it seems like maybe that's putting the control in the wrong place. Like what is gen package? Gen package is just like sift, right?
Yeah.
And like, should the platform just handle running that?
I think the last time we discussed this between at least Stephen and I, we decided that we ship that with some extended version of the lifecycle if the platform or is cares enough about the gen packages to replace it, they can do that, and then provide a way for the base image to have an attached SBOM in case we are just reusing the base image as it is without extending it. So the idea was like the project provides some binary that's gen packages that conforms to a specification and so on. If someone cares enough about it to change it, they can write one and bundle it. And for Stack authors or app developers to provide it, they can attach it to the image in some, like one of the other attachment formats, and then we can just use that. So that was month or so ago when we discussed it.
So if we're trying to keep our run image totally generic, right? Like, doesn't need any special build pack specific internal API against the lifecycle. I think that makes sense. I worry about like a distro list like image, right? There are things that Sift is just never going to deal with, right? Like an implementation of gem packages that's just run Sift against it is not going to work for a lot of existing use cases, right? So there needs to be some way for gem packages to understand at least there is a pre-existing SBOM for this image that isn't going to be replaced, right? or something like that, right? There needs to be an additional needs to be more functionality than just gem packages as Sift, and Sift runs every time and replaces the existing SBOM, right?
Yeah, I think this is pointing toward a long-standing question that I've had on the Docker files track of work. I wonder if we could maybe pivot a little bit toward that, because we'll probably end up circling back around to this anyway. Let me find it. So I have this, this is the spec PR that kind of introduce, more formally what changes we want to see. And one of the questions I've had for a long time is, extensions are supposed to, they are like expected to conform to the build pack API interface as much as is reasonable, right? And there's like specific exceptions that are carved out. One of the things that we had said is, where is it? So this is the question, right? Can image extensions write SBOM files? This would be during the generate phase, right? So before Docker files are ever applied, but maybe they know what would happen if the Docker file was applied, and they want to provide a file that's like, here's an SBOM for the thing I'm going to do. Do we want that?
Sorry.
Like the analogy saying like the extensions are the build pack API. I find it persistently confusing because it's different enough, right? Like what we're doing with launch toml and build toml, maybe we're calling them launch toml and build toml, but they're serving a different purpose, right? And therefore we end up asking these questions, and like I don't know exactly what the answer is for the SBOM question, but I feel like we end up framing it because it's like, a regular build pack can do X, but it's the things that are happening are different enough in these cases that I worry that saying it's just like the build pack API except for 7 exceptions is not the most helpful way to think about it sometimes. I don't know if other folks agree with that or have found that to be a point of confusion in these conversations.
I think I put a comment on some spec change that was like, we keep mixing the word extension and build pack in a bunch of places. We should, come up with separate terms for those things. So I definitely
Can
agree.
it create an SBOM, I guess is the question, like for the change it's going to make. I think it gets awkward because, you know, when build packs are making layers, they're all making totally disjoint layers. So they can each make an SBOM that describes what happened in their layer. And then all those SBOMs together describe, you know, everything that happened in the layers directory or other in the app or changes that build packs can make. But in a Docker file case where you're sort of applying change set on top of change set, like, I don't know if you can say the sum total of all those SBOMs is meaningful, especially if we're letting someone just totally like replace the run image halfway through that process, right? Like, you kind of have to wait till the whole thing's done and then SBOM it.
I wonder if this functionality, right, which is like the same functionality the build pack API provides to let build packs contribute SBOMs for their layers, is supplemental to what gem packages is doing in a way that means that we don't have to deal with some of the complexity of like, you know, image specific gen packages functionality. Like does this, if you can say, when I run the snippet of Docker file that curls something off the internet, right? I'm going to be okay with the fact that SNCC isn't going to pick, or SIFT isn't going to pick this thing up, right? Because I've kind of manually, you know, created that metadata outside of the process, but it doesn't replace gen packages, which is like a, you know, way to kind of scan the image for things you want in addition to what you've put there, something like that. So like Sam, to answer your question, how can I write SBOM here without access to the actual files, right? Maybe the answer is this is the place where you can contribute SBOM that doesn't require the actual files, but there's another place to contribute SBOM that does require the actual files, which is, you know, kind of how the, well, yeah. What do you think?
It's too many places with SBOMs.
I can imagine this common use case, right? That's like, I need this extra dependency in my application and it needs to be installed into user local. And so I curl something and install it into user local. But now like, you know, this isn't a base image I maintain. I'm not going to replace gen packages on it. There's no way, you know, there's no place for an SBOM to be associated with, you know, curl. And I don't want to pull tools into my, you know, start a multi-stage Docker file, right? And then use a SBOM download an SBOM generation tool to run on curl, right? Sorry.
The issue there would be, so like, again, the way we deal with this right now is whatever artifacts that we're untowering and installing in the image have a folder where it contains the SBOM. And we just reuse that. So like, even if the thing that's doing run, curl, tarball, blah, doesn't know about the actual SBOM in the thing, it can still produce an SBOM. So the idea would be, if there's just an SBOM file there, or gen packages would pick it up. Because here, whatever is the extension is just writing the Docker file, right? It's not actually executing the steps. So at this point now, it has to both write the Docker file, and if it's putting tarballs in there, it has to fetch the appropriate SBOM as well. Whereas in this case, it just has to write the Docker file, and if the tarball contains the SBOM, we just pick it up.
If you're installing a specific version of a piece of software using a Docker file, I think it's going to be easier to write the Docker file that installs the specific version and then write the SBOM entry, not inside of the Docker file, but outside of the Docker file, right? In order to capture that thing. But
how?
Look, like in your case, you're saying the SBOM is pre-generated, right? And is available somewhere else, but I don't think that's always going to be true, right?
So like, you I also have to drop in a minute, but you're saying that whatever is writing the Docker file also knows how to write the SBOM without inspecting like whatever it's running or downloading. Like,
I'm saying in cases where you're installing a specific version of a piece of software using a Docker file, right? Then if there's not a snippet of SBOM configuration somewhere that covers that component, it's probably easier to do that in the build pack than the Docker file. And so I could see a use for keeping this API available,
I mean,
but I don't think it's complete. Yeah, sorry, go ahead.
Take the example that we're most likely to end up using here, where the Docker file the extension will be writing a Docker file to install a system package via DNF. So if it's installing a JDK, we're not going to know the exact version of it. We'll just know that it's N11 capable JDK, and the patch level's taken care of by whatever the upstream repository is. So there's not going to be a particular SBOM that's going to be wrapped around nicely pre-declared for me to download from anywhere and use. It's going to have to be generated once that system's put together.
But that doesn't work through this API though, because this API doesn't give you the version of the thing, right? This API would only be useful for, exactly the version of the piece of software ahead of time, and you don't have a pre-generated SBOM somewhere for it, right?
Yeah, I mean, so I would know like the rough version that it's going to install, and I know that it's going to install it during the extension. It won't be installed, obviously, until after the Docker file layer is applied, and then I will know exactly what version it resolved.
Yeah, exactly.
But rough is probably not good enough for an SBOM.
So
right.
That's why I'm saying for things like system packages, you already have gen packages that will produce an accurate thing. The only real case where like we'll be providing or adding value is like when you're downloading random files, right?
Yeah. Okay, so I don't care that much about having this API. I think it's probably safer to not include it initially because it's easy to add back. It's purely additive non-breaking change to add an additional way of contributing SBOM. So do we all feel like we want to cut this API?
I mean, worst case, you can just write a Dockerfile instruction that says run echo blah, put it in the layer if you really know what it is, and
you could just templatize or like literally put the string in the Docker file for the SBOM thing you're gonna generate. That makes me want to keep the API so that people don't do that.
I mean, this specific API is for like a really small edge case, right? Like the thing that's applying the extension knows the world accurately enough that it can produce an SBOM, but the original artifact didn't.
Yeah.
It's a artifact that you downloaded as a random file off of somewhere.
It's that it exists in the build pack API already, right? And so like, I'm just thinking about the experience of like a new extension author, right? Who knows the build pack API, isn't familiar with the extensions API, right? Any similarity to the build pack API is going to be good. And so if it's easy and obvious for how they, for their one weird Docker file that grabs some data from somewhere and puts it in the image, how they contribute an SBOM for the change they made. If it just looks exactly like the build pack API, right? That feels pretty good. But I agree that in most cases, it's, they're not going to have enough information to contribute a realistic SBOM, right? Entry that because many of our Docker files aren't going to be curl, this go binary from the internet and put it at this place, right? So I'm comfortable saying we cut it for now, if you'd like.
I need to drop.
I think I was pushing toward taking it out just also for simplicity, but if we wanted to keep it in, I had a question about, oh my gosh, where it should go. Basically, instead of putting it, if we put it in layers SBOM extension ID, it could, like, extension IDs can collide with build pack IDs, right? And that seems not optimal. So we could put it in like layers SBOM extensions, or layers SBOM launch extensions, or, you know, just have like some top level directory holding all the extension contributed SBOM files. And then we just have a reserved build pack IDs. Like, you can't make an extensions build pack.
So you're talking about in the Docker file that's being generated, right?
Yeah.
Like, or you're not talking about in the outside of the Docker file. You're talking about now the Docker file is running and it's running on the build image, and you want to store it in the layers location, or the, sorry.
So I'm just looking at this spec line, right? We're saying that the final exported image must contain a layer containing build pack provided software bill of materials files, right? Which is usually in, you know, layers, SBOM, launch, build pack ID, right? And I'm saying, you know, we just need like a subdirectory to hold all the extension provided ones, right? Because otherwise it's, you can have
so the way the RFC is phrased, and I don't know if the changes we've talked about change this at all, right? There is no, it doesn't make sense to have an SBOM contributed by an individual extension, right? What happens is each Docker file runs, and then gen package runs and replaces the past SBOM completely, right? And so the question there is, if one of the Docker files wants to contribute something additively, right? It's not going to rely on gen packages to run and then regenerate the SBOM, right? There's additional SBOM configuration it wants to add. What does that look like? I mean, we just cut one API for doing that. Is there another API that we're adding? Like, is there a place in that the Docker file is supposed to produce SBOM? Or like, yeah.
Oh,
it's separate from gen packages.
I think I made it more confusing than it needed to be. I'm basically saying, if we want to just cut, extension provided SBOM files in the extension output directory, then my question is not relevant, because this is like an extension or build pack output SBOM files. We copy it to a location in the final app image. Where should that be? That's my question. But if that's not the case, because why?
Because we're not going to provide an API for the extension itself to output an SBOM.
Yeah. I think we should take it. There's like too much uncertainty, right? It's like, even if we provided that API, does it make sense for it to just be a file in the final image? Like, I thought we wanted, actually don't really know what the output of gen packages looks like. So maybe that's another open question. But if we could take it out for now and just add it back if we need it, that I think would unblock a bunch of stuff.
I think we can take out that part of the API. That wasn't. I don't think that part of the API was in the original RFC. So I'm pretty sure, at least. I forget, but so it seems reasonable to me to take it out. But I think there's another. It's going to come back, right? And that, like, there probably needs to be a way in a Docker file. It's like maybe there's some hook, right, where the gen packages binary knows about a special location on the image, you know, that it's running in, where it pulls additive SBOM entries and appends those, or, you know, includes those with the SBOMs that gen packages generates. But maybe that's more about the gen packages API as opposed to the, you know, lifecycle API with the extension. Maybe the idea here is that SBOM is handled completely outside of the lifecycle, right? In this case, except for, you know, the output of gen packages running every time against every, you know, intermediarily generated image, something like that.
Okay, I think that helps. I mean, I think we're not closing any doors, right, to, you know, future improvements that we might want to make. I did actually, so I had one more question in this area. which was around what happens if I'm just using Docker files to switch the run image? Do you still want to run gen packages, or do you want to say, hey, the platform is just intending to use another known run image that already exists. I'm going to return the reference back as a result of running, the extend phase, and the platform is going to give me an SBOM.
Oh, that's interesting. So if you, I kind of feel like we shouldn't special case, right? Changing the base image, like if you said, this is my run image SBOM, and then, like, because we've said that it's going to be an input to the lifecycle, right? If you say, this is my run image SBOM as an input, and one of the Docker files, and many Docker files, changes the base image, right? We're not going to request that the user give us another SBOM for that image, right? We have this gen packages API that's intended to replace the SBOM on the run image entirely, right? And so I think gen packages is probably the tool that does that. And it's just becomes, again, important that gen packages be able to read an SBOM that's on the image, I guess. If there's a special, SBOM format that gen packages can't pick up, or like special, if there are additional changes to the image, right? When you swap the base image to something else, it needs to be possible to provide additional entries, something like that. I don't know. To me, that comes back to like, maybe we do want that other API, because if you're going to change the base image, then you do know what you want your SBOM to be, right?
Yeah, because we'd be looking at doing something like this, because for the golden path, where if it's just a Java application, there are already UBI8 images out there that have a JDK installed. So it'd be easier for us if we could just swap the run image straight to one of those, and we don't need to worry about it. But we'll know what's in that image in advance, because effectively at the moment we'd have to knock it up as like a whole bunch load of parallel stacked run images. So they'd all have the CNB lifecycle stuff already in it, ready to roll. And it's just a question then of during the build thing, we'd write a Docker file that swaps the run image from our empty one that handles the generic case to the pre-existing one that we know handles this particular case. And then if somebody does something awkward, like writes an app that needs Java and Node simultaneously, we lose the ability to be rebaseable, but we have to install the runtimes ourselves. And with them, we can't do the runtime switch. We just have to apply it bit by bit.
When you swap the run image, you need to be able to swap the run image SBOM, right? And just like the lifecycle takes in it, like we've made it so the lifecycle doesn't read the SBOM in a standardized format, right? So I would say that's interesting. I would say if the lifecycle is going to take the SBOM as a separate argument from the run image, then we need to keep the buildpag API like external SBOM, because when you're swapping the run image for a different run image, you need to be able to provide the SBOM for that run image outside of the context of the Docker file, right?
Not necessarily, right? Because we're returning the reference to the run image back to the platform, right? So we could still say, hey, it's the responsibility of the platform to figure out the SBOM for this run image. And so, all we do is, here's what the final run image was, right?
Yeah, but
how?
I was going to say, practically, there's no way to do that, because you'd need to be able to predict which extensions ran to know which final image you ended up with, so that you could predict which SBOM you now need to apply. It's the knowledge that we need has already happened inside the magic box.
Does it? I mean, I'm thinking of after the extend phase ran, right? So after you applied all the Docker files, and like, let's say the last Docker file was from my new run image, right? Then the result of the extend phase is like, okay, well, I didn't actually have to build anything, but here's the image I ended up with. Oh, it's one that already exists in your registry, right? Then you call export. That's the next phase. Give me an SBOM to use.
Like, say you have a bunch of extensions, and like, one in the middle swaps the image with a different image, right? like how, and then it's the other extensions keep building on top of that, right? The platform is just going to get back, like at some point the base, maybe the platform would get back. And I think this is actually more information than I think we should expose, but maybe the platform would get back. The image changed to this at some point, and then there were more changes to it. And I don't have a, like maybe I could give you this digest of this intermediary, but it would create this very complex API, right? Where the platform
You have a
would be
flag
like,
for that though. Essentially, the rebasable flag is covering that distinction. Because if rebasable is still true as you come out the other end, then you know you've swapped to an image that didn't have any further modifications from extensions downstream. Whereas if rebasable has gone false, then you know that you still have to apply all of those things if you ever want to build a new run image.
but isn't this like, are platform authors really going to understand about all the possible extensions and all the images they could install, and then attempt to determine what SBOMs map to the images that those extensions would have changed, right? Like it.
No, there would need to be a spec standard way, wouldn't it? It need to be the platform knows that if this happens, it can look in the image and pull the SBOM from a location.
Right. So maybe the solution here isn't we should provide this API, that we should provide this open API at the build pack level because we've provided the open API on the lifecycle side. Maybe the solution is we shouldn't provide the open version of the API on the lifecycle side. And we should standardize on, like, Sam was saying, pick cosine attestation format, right, as the way that SBOM will be specified, right? And then now we are allowed to integrate reading the SBOM from a new image directly into the extensions API, right? And so, like, when you do a lifecycle build, lifecycle pulls, the image, right? Sees if the image has an SBOM associated with it, and in every stage of extension, the lifecycle can look at the digest, right? See if there's a co-labeled digest and pull that as the extension, and then automatically know as the run image changes if its SBOM changes. I think that's got to be the only way to do this. Does that make sense?
Yeah.
Like if you change the image in the middle, like you have a whole bunch of extensions that are running, right? And you change the image in the middle to a new one, right? All you have to do is at every stage of extension running, you take the digest, right? And you go back to the registry and you see if there's an attestation associated with it. You pull that SBOM, and that SBOM becomes the new SBOM for that image.
And if there's no SBOM,
you run gen packages.
Run gen packages.
I like that last one because at the moment, none of the stuff I'm messing with has SBOMs in place anywhere, and it just needs to work.
Right.
So,
right.
And that's the problem, is when you get into the more detailed scenarios like you're talking about there, I can't offer any sensible opinions at that point because I'd need to have actually tried playing with that stuff, and I haven't. I'm miles from there still.
That makes sense. But this way, it works when you don't have any SBOMs for anything, and you just want to comply an image at the end. But it also works. The behavior gets better if you start providing your own SBOMs, along with those input images, and it just works automatically.
Yeah, because I already think there's a big kind of buyer beware sticker if you try changing the run image multiple times from multiple extensions, thus losing all of the stuff that's been aggregated to a previous run image along the way. But this is, you've got to figure that the person building the builder image that assembles which extensions are possible to be in play is responsible for, in a way, creating a universe where you can't screw up that badly, where when it runs, you don't have an extension that says, I think this is an application of type X, I'll swap the run image to one that provides X. Then another extension runs, no, this is an application of type Y, I'm swapping to that. And you're like, okay, well, X is going to be very unhappy now, and we can't guard against that. That's I don't see there's any way to fix that from a much bigger picture kind of perspective. And I think the SBOM stuff plays into that same problem when you get there.
Yeah, I think at least in this case, if the base image changed multiple times, right, you would either be getting the SBOM of the last base image automatically if it exists, or you'll be getting the result of running gen packages against the last base image if it exists.
Exactly. So whatever you end up with, you're still being consistent. It may or may not work, but that's a different question.
Right, totally. Yeah. Okay, so strip SBOM out of the API entirely, right? If the gem packages is, or if there are two two ways the lifecycle knows about base image SBOMs. One way is in a standardized image external format, probably cosine attestations, but we should argue about that more. Because cosine also has a separate SBOM format, right? Actually, I'm curious, Ozzy, if you have, I don't know if I've heard, if you have preferences on SBOM storage.
Again, I've not even got to SBOM stuff, so I've had no preferences there at the moment. I just expect that there needs to be a way for it to work while I still have no preferences. You know what I mean?
Got it.
Gem packages is my friend there. So
we'll argue with Sam or whoever or somebody about if it's cosine attestation format or cosine SBOM format, but we'll pick one of those two things. And I guess we could do both. You know, we could have like some order where it tries to look if it's using the specific cosine SBOM when it looks for that. If that's not there, then it looks for an attestation that has SBOM in it. Maybe, I don't know. We'll figure it out. Use that external format. Get rid of the internal API for SBOM. The two ways that the lifecycle knows about it are it's going to look for that external format on every time, right? Like even if the Docker file runs and changes stuff, it's just every time. Take the digest you have in the end and go look it up, right? Because it's always safe because it's by digest. If somebody said this SBOM is for this digest, we should do it. Maybe it's a reproducible Docker file, right? Or something like that. And we can reuse the SBOM, from many previous runs and not have to run gem packages again, right? So like at every stage, the process is maybe even at the first stage for the first run image we pick up, right? It's always the same process. It's just go out to the registry, look for an SBOM associated with this digest. If there is one, use it. If there's not one, run gem packages. And it's a simple API that happens everywhere, anytime that an image switches, even for the build image. Sorry. Going on a tangent a little bit.
Does that complicate the thing? So I remember this came up in the last discussion. What happens if you're not working with a registry, right? You're running with a daemon. Now you can't rely on there being a digest, right?
So in the daemon case, there's still going to be, so it's like in the daemon case, if you started you're going to build an image at the end, right? Like at the end of each extension, you're going to have an image output at the end. Do we not ever get it? It would be too expensive, right, to recompress the image between each step and try to calculate a digest for it just to have an ID that would be a consistent way of pulling the SBOM, right? It seems like that's a bad idea. So I think in the daemon case, we need to come up with an analog to pulling the SBOM from the registry. That's probably a file or something like that, right? Like if it's the daemon, you're talking about local storage for your images anyways, maybe. And so in that case, is it like we take the image ID, right? And then we look for a file on disk in a certain place that has and we just replace that operation of reach out to the registry with look for file in SBOM folder, right, in location and pull SBOM from there if it exists. Last thing. Maybe when we implement the stuff in pack, it's going to do more mirroring of the daemon into the registry, kind of like getting rid of daemon support, right? Part of that could be if you're doing builds against the daemon and the images came from the registry, the SBOM already gets pulled into like .pack/SBOM and associated with the image. And so we preserve the SBOMs that you've pulled from the registry remotely, and it just works. And the lifecycle uses a file-based API that uses the image ID for finding the SBOMs at each stage, something like that.
I do wonder. I mean, I think this all makes sense, but I wonder if, at least in my mind, it was all a little bit simpler, and I wonder if I'm missing something. So it's like, I'm thinking from the lifecycle's perspective, right? The lifecycle has a bunch of Docker files. It knows, right? The lifecycle knows at the end of running extend phase, did it create a new image or not? Right? Because
sure.
Right, if all that happened was you switched the from image, right? Then it knows okay, I didn't create something new, right? There was something that existed before. In that case, it can just like spit the reference back to the platform. Okay, give me an SBOM, right? If it had to save something new, then it runs gen packages. So sort of kind of make it like either or.
So the only difference between that and what I was proposing is that instead of looking for the SBOM in a standardized format at a location, it's querying the platform. The platform could implement looking for the SBOM in a standardized location, right? I'm thinking about that. I think it's the API where in the middle of the build, the life cycle has to, because in the end we want that SBOM to be incorporated into the app image, right? Saying that in the middle of the build, after the extension phase, right, the platform gets the image back and has to make some decision about it. I guess that's not terrible if it's like, could you overload gen packages? So gen packages runs either in the context of the image, right? And then, it can generate an SBOM for the image. Or if you provide gen packages with a image digest, right? Or a fully qualified image digest, then it pulls the SBOM and it's a package that's distributed to the life cycle. And that's the way the platform can requery, right? And then we could open up the API on the other end again and say that you have to not standardize in a format, right? But it seems like it might be better just to standardize in a format. And then you don't have to worry about do we not like standardizing in a format? Is that the problem?
Two that Sam will always mention is the cosine attachment and then in total attestation, which to my eye, there isn't a clear winner.
You could look for both though, right?
Yeah. I wonder if just for the purposes of the more flexible way seems easier. I don't know. We could get feedback on it and then decide. I would by the way, I've said this in other forums, but I really, really want us to ship. When we do ship support for this, it should be in an experimental API so that we can be free to make changes to things that don't work.
Yeah, that seems great.
I know we're coming very short on time. I wonder if it's possible just in the last couple of minutes. There's a few open questions. I feel like we're kind of approaching something that may work with this SBOM stuff. I just want to make sure that I get input on other things that could unblock.
Go for it.
I'm going to skip this one because this is SBOM. I don't think anyone really cares about this other one for the time being. Nothing. Just want to make sure that I didn't. Okay, we talked about this. This was what I just said about, did we save something new? In the short time that we have left, I just want to ask anyone who cares to please look through the list of allowed Dockerfile instructions that I've put here. I think that was an outcome of a previous conversation. We should be explicit about what we allow, what we don't allow. So for just the philosophy that I used to try to come up with a list was, with run Docker files, it's pretty much anything goes, who cares, right? You're just building a new image. But for the build extensions, because we're kind of keeping the context around after they've run in order to run build packs right after in the same container, a more limited set of instructions makes sense.
Yeah, they have to use the arg format for the thing. Yeah.
Yeah. And then there's some questions about how restrictive we should be, which I think, Ozzy, you were of the mind that like people should know what they're doing. If they're going to shoot themselves in the foot, like, okay.
Yeah, I mean, I've tried it. It's doable, but it does have caveats around it. So I'd be quite strongly against making that a must not and make it a should not.
Well, could I think the big problem is that it's going to be really hard for some platforms, that don't have a daemon, for example, like to during the build process switch the image that is actively executing to a different image, right? To a dynamically generated image that's not known ahead of time. That's been a bit like a hard problem. If we keep this a must not for now, and then we come up with a platform that can reliably, like if we say for now all the buildings have to start with this, right? And then later we have a platform that has a reliable way of implementing swapping the build image right through a Docker file, and we see that it works, then we can change it to a, we can even just get rid of the requirement, right? What I worry about is like allowing all extension authors to do this, but then the extensions that do this don't work on any platforms, right? So like, because Lifecycle isn't going to support it, like I wonder if we can keep the strong requirement in for now, and then if a platform shows up that says, hey, we'd actually like to support this, then we change the API and say, okay, now extensions can do this, and only at that point. And then we have to deal with like, people are going to write some extensions, they're not going to run on all platforms, and we have to deal with managing that, right?
Yeah, because I mean, the current proof of concept supports this. So to be clear here, I agree with the must begin with arg base image from base image. It's the second must not contain any other from instructions, that one, because it's the ability to start from the base image you've got and then swap over to another one, and then as I did, then use a copy to bring the CNB folder over from the original one, so you've still got access to the stuff you're supposed to.
I'm late for my next meeting. I really got to drop. We should. I don't have a super strong opinion about this one, but I think it's a little safer to keep the restriction.